Now we're going to try to solve a problem using the drag force method. So given in the problem statement, we know that the design discharge that we're trying to design a channel for is 500 cubic feet per second. The bottom slope is going to be 0.0004. We know that we're designing it with gravel with a particle size of about 2 inches that's slightly rounded. We know that the water's got a low concentration of fine sediment. So the first step in this process is to determine what is an appropriate side slope. So we know that we're using gravel, so we're going to select a side slope of 3 horizontal, 1 vertical. The next step in the process is to determine what the angle of repose is. Now for this you're going to need the figures. The angle of repose is a function of the particle size and of the fact that it's slightly rounded. And so we're going to look at the figure and we can determine that the angle of repose is equal to 24 degrees. Now we want to look at the next figure for critical shear stress on the bottom because this is it's a function of the particle size and also that the water is a low concentration of fine sediment. So looking at the correct figure, as you can see, we'll determine that the critical shear stress is equal to 0.17 pounds per square foot. Now we know that the allowable shear stress is going to be greater on the bottom than it is on the sides because the sides are going to be less stable. And so in order to determine what the critical shear stress on the sides is going to be, we're going to use this equation. And we're going to need to solve for K. So K is equal to the square root of 1 minus sine squared theta, which is the angle of the side slopes divided by the sine squared of the angle of repose. So since we know that the side slopes are 3 to 1, we can find out that that angle is equal to 18.4 degrees. From there, we can plug in and determine what K is. Good. And that's equal to 0.63. So now we can plug back in and determine what the critical shear stress on the side slopes is going to be. We'll have 0.63 times our critical shear stress on the side slope. And that's going to be equal to 0.107 pounds per square foot. So the next step is we're going to solve for the depth of water in the problem. And so we can use the equation. The shear stress on the sides is equal to 0.76 times gamma, which is the specific weight of water, times the water depth, times the slope. And so we know that the specific weight of water is 62.42 pounds per cubic foot. We also know that the slope is 0.0004. So plugging in what we know for the shear stress allowable on the sides, we can determine y. So rearranging here, y is equal to shear stress on the sides divided by 0.76 divided by gamma divided by S naught. So plugging in our values, we can get the value for the depth of the water. And our final depth, design depth, is 5.64 feet. So now we're going to need to determine the bottom width. To do this, we're going to be able to use Manning's equation. So here we have so we already know what Manning's equation is. We know that the Q for our design is going to be 500 cubic feet per second. Because we're using foot-pound units, we're going to use K is equal to 1.49. We know that N for gravel is 0.04. And we know this bed slope. What we don't know is the hydraulic radius and the area. These are going to be functions of the bed width and the depth. Since we don't know the bed width, the whole equation is going to be a function of V. So Q is equal to 500. And the hydraulic radius is going to be the area. Divided by the perimeter. So 2/3. And then the area is just going to be a function of bed width and of y. And then all this is going to be multiplied by the square root of the bed slope. And so z we know is 3. And y we just previously solved would be 5.64. This is a pretty complicated equation. And so you're going to plug in the numbers, and then what you're going to want to do is plug it into your either the MATLAB equation that we've given you, or Wolfram, something like that, to determine the bed width. And after solving, you get that the bed width is equal to 18.9 feet. So now you have all your design parameters, and you're good to go. Yeah, I don't really know like what to say. It's like freaking hard. I'm not gonna